Hello everyone, welcome back. This is Introduction Part 1. In this lecture, we'll discuss and introduce cloud computing. This is our agenda. What is cloud computing? Different deployments and models, advantages, AWS suite with some analogy, virtualization in AWS, and then Zen hypervisor. What is cloud computing? Before giving away the definition of cloud computing, let me try to segregate the two underlying facets of the same. One portion is cloud and the other portion is computing. Before defining cloud computing, let us see some basic definition. What is internet or intranet? If you are using this computer, if you are using your computer and internet connection to watch this course, then you know what internet is. Internet does not need any introduction, without which our lives would be totally different. So this is the technical definition. A global computer network using standardized communication protocols, for example UDP, TCP/IP, providing information and communication facilities consisting of interconnected networks. So we have a global network. There are thousands of routers provided by multiple internet service providers, and we have billions of devices. Each are connected to each other using this global network. If I send a WhatsApp message to you, I'm essentially using internet. Then what is intranet? Internet is same but within the same network. For example, you might have multiple devices behind your router, like your laptop, desktop, one or more smartphones, tablets, etc. If you are using Wi-Fi router to connect to internet from these devices, then all these devices are said to be in LAN or local area network. They do not need internet to talk to each other, as the communication can happen via the router. Then these devices are said to be using intranet. Internet is a local private network created using World Wide Web. We'll see intranet in much more detail later on. Okay, so why am I talking about internet or internet all of a sudden in a session of cloud computing? Remember the first facet? Cloud. Well, cloud is nothing but a fancy name of internet or intranet. As long as there is network and connectivity, we are in cloud. It might surprise you, but yes, that is the definition of cloud. Cloud is actually internet or intranet. So one definition down, let's define computing now. When we say computing, a picture of computer comes in our mind. Computer contains CPU, RAM, hard disk, operating system, maybe Windows, Mac or Linux. But compute actually means CPU and RAM and the other components in a computer's motherboard. In enterprise or corporate environment, when you say like server, we mean both compute and storage. But actually a server contains only the compute environment, CPU and RAM. I'll stick to CPU and RAM for the moment to define compute. Before going into compute further, let's introduce virtualization. Suppose you have a Mac OS and you need Windows operating system to do some of your work. You have two options. First, the easy one, buy a Windows laptop. But think for a moment, you'll not use either of the machines all the time, right? Some of the times you'll use your Mac OS or Mac laptop and Windows laptop in other times. Then what is the point of spending so much money in buying a new system? What is the second option then? Welcome to the virtualized world. Now, what you can do is install something called VMware in your Mac OS and then install Windows on top of VMware. If you log into Windows, it'll feel like you're using a separate machine altogether. But actually, you are not. The Windows OS will get its own RAM and CPU, but that will be borrowed from the virtual Mac machine, from this one. The Windows OS will get its own RAM and CPU, but as I said, it will be borrowed from the Mac machine underneath. Now we say that this Windows OS has been installed as a virtual machine. The reason it is virtual is obvious, as it uses virtual CPU and RAM borrowed from the host OS, in this case Mac OS. VMware, which is used to install Windows OS, on top of it is also called hypervisor. Hypervisor is a technology that is used to create virtualized environment. In our case, we have virtualized CPU, RAM, and storage as well. Storage because this Windows OS will need to store the operating system itself along with data. So virtualization is the creation of a virtual version of something such as operating system, server, storage device, or network resources. You see, server, OS, network resources, storage, everything can be virtualized. Now if you see here, we have saved ourselves buying a new computer or laptop by just creating this virtualized environment. We'll discuss virtualization concepts in much more detail when we come across it again in later tutorials. But think of the money which you have saved. You did not have to buy another laptop. You are using the same machine and you are using two operating systems. Basically, you have saved half of your money. By now, you might have guessed that cloud computing uses virtualized technologies. So that enormous amount of compute environment can be created with lesser cost. So the compute portion of the cloud computing is actually virtualized compute environment. However, it goes beyond only compute, as we'll see in due time. Let's define cloud computing now. If you take the virtualized environment which we just created in the previous slide, as in Windows OS on Macintosh operating system using VMware, and put it over internet and allow users to access the Windows OS remotely from their machine, well, congrats, you have essentially created a cloud computing environment. So if you ask me an one-liner definition, this is how I would define cloud computing. So cloud computing is virtualized compute environment over internet or intranet. Why internet? We'll come back to that. So cloud computing is equals to virtualization plus internet. It's a combination of both. Now different models and deployments. So cloud service models. We mainly have three types of service models: infrastructure as a service, platform as a service, software as a service. So infrastructure as a service, we have AWS, Rackspace, Microsoft Azure, Google Cloud Platform, IBM Bluemix, etc. In platform as a service, we have AWS's Elastic Beanstalk, Heroku, OpenStack. And then software as a service, we have Google Drive, Google Docs, Microsoft Office 365, etc. See that as a service, this one, the last one, EAS, we have been using this as a service for a long time now. Before going into technical, let me try to describe it using an example which you can relate easily. Suppose you want to eat pizza. You have two options. Of course, first option, go to a restaurant, order a pizza, eat and pay for it. In this case, you are using as a service. In our case, this would be food as a service because you are not only buying the product, you are getting served as well. What is the second option? Cook it yourself. To cook pizza, you'll need multiple things. You'll need kitchen utensils, then you'll need vegetables, then you'll cook and get your final product, which is pizza. And of course, you'll have to eat it. Right? If you see here, we need multiple things to get our end product. The kitchen utensils which I was talking about is part of infrastructure. The vegetables and etc. is part of platform. Then we have cooking. And finally our product. Now if you plan to cook yourself and if you're in a new place, you have to invest a lot of money buying infrastructure, then buying platform, and then you have to cook yourself and then consume it finally. Let's talk a little different. Suppose you are a person who wants to buy your own stuff like vegetables and cook it yourself, but you do not want to invest on infrastructure or kitchen utensils. Of course, you are in a new place. It don't make any sense that you buy infrastructure every time you go to a new place. What you can do is go to a hotel, book a suite, and use their kitchen to cook pizza. So all these things will be provided to you by the hotel provider. What you have to do is you have to buy only vegetables. You have to buy and pick your own vegetables. And then cook your pizza. Then in this case, what you're essentially doing is you're using someone else's infrastructure. So you are using infrastructure as a service. So you're using the infrastructure and paying for it. So you're taking infrastructure as a service, but you're still buying and picking your own vegetables and cooking it yourself. So you're creating your own platform and of course cooking. Let's say now you're a person who just wants to cook your own stuff. You don't bother about picking vegetables. You don't have time for it as well. So now you tell the hotel staff to buy vegetables from the list provided by you. In this case, you are using someone else's infrastructure and you are using someone else's service to get the platform. So in this time, you are using platform as a service. When you are using PaaS, infrastructure as a service comes by default. You don't have to ask for it separately. I mean, if you do not have kitchen utensils, you cannot cook a pizza just using the raw vegetables, right? And then finally, you have restaurant. You can go to a restaurant, go to a pizza shop, order pizza, and buy yourself. As I said, food as a service. Now let's talk a little technical now. Suppose you are creating a product or a mobile app and you'll use Java to create that app. Let's see what things you need. First of all, infrastructure. You'll need server, database, storage, network, etc. And what platform you'd need? You'd need operating system, Java virtual machine, Java, some IDE like Eclipse, etc. Then it'll cook. In our case, you'll code. Then create your final product. And the product would be used by the end users. Now if you see here, you can follow the exact same process which was used in case of pizza. You can choose to use infrastructure as a service and create your own platform, like install your operating system, basically install your JVM, then install Java, then install IDE, then code and create your product. And use this one as a service. Get it from someone else and pay for it. Right? Or you can use platform as a service. So in this case, OS, JVM, Java, IDE, operating system version, everything will be pre-installed. You don't bother about those things. You just code and get your own product. So in this case, you are using platform as a service. Now for the end users, they don't care how this product was made. They just want to use it. They don't know whether it is being written in Java or you're using Eclipse or something else, what database you're using, what server you're using. They don't care about it at all. They're just using this product. So for the users, it is software as a service. Right now, in infrastructure as a service, AWS, Microsoft Azure, Google Cloud, etc. mainly deal with infrastructure as a service. They also have huge platform as a service base as well. We'll discuss them in due times. Let's see how these service models fan out for typical enterprise data center.